Today we're going to solve systems of nonlinear equations algebraically. We've already been working on solving systems of equations graphically, so we're going to use that today to kind of help visually show the solutions that we are solving for via either substitution or elimination. So the first thing I want to do is graph my system. So I'm going to take this first equation, y minus x equals 5, and based on that equation I can tell that it's a linear equation. And when we have a linear equation, we typically want to solve for y in order to graph. So I'm going to solve for y, and I'm going to get y equals x minus 5. So I'm going to start my graph at -5, and I'm going to go up 1 over 1. And I can also go the opposite way. And then I'm going to draw my line. Now I'm going to graph my parabola, which is my second equation, using opposite of b over 2a. And I'll find that my x is 3. When I substitute 3 back in, I'll find that the y of my vertex is -4. So I'm going to start my graph at 3, -4. I'm going to use my pattern to then graph my parabola. And I want to do as many points until I see that the line and the parabola intersect. So I can see that my solutions are 2, -3, and 5, 0. So now I'm going to do the same, use the same two equations, but now I'm going to solve by substitution. So if I have x minus y equals 5, and I have y equals x squared minus 6x plus 5, what I'm going to do is I am going to take this second equation, that's y equals, and I'm going to take what y is equal to, and I'm going to substitute it into the top equation for y. So my new equation will be x minus, notice I'm using parentheses, because that will make sure that I subtract the quantity, not just the x squared. So I'm substituting that in the y spot, and so it's going to equal 5. Now I want to simplify this so I can solve. So the first thing I'm going to do is distribute that negative into the parentheses. So I'm going to get x minus x squared plus 6x minus 5 equals 5. Then I'm going to arrange my equation so that way it's in standard form and equal to 0. So my negative x squared will go first. I'm going to have plus 7x when I add my x and my 6x. Then I'm going to minus this 5 from the other side of the equal sign over. So I'll have -10. Now I want to factor this. Since my x is negative, I'm actually going to start off by factoring out a -1. That way my a value is 1. It'll make it much easier to factor. So now I want to find two numbers that multiply to 10 but add to -7. So those two numbers are -5 and -2. So now my two solutions are going to be x is 5 and x is 2. Now, when we solve quadratics, we would be done after this point, after we checked. But now we're solving systems of equations, and systems of equations will always have a coordinate. These are just the x's of the coordinate. I need to find the y's of the coordinate. So I need to take these 5s, and I'm going to resubstitute them back in to one of the original equations in order to find y. Now, you can substitute into either equation and you will get the same answer, assuming you do your algebra correctly. Typically, it'll be easier to substitute it into the linear equation, which was the first equation. So I'm going to substitute it. I'm going to use this linear equation, x minus y equals 5. And I'm going to substitute 5 in for x. And I will get that y equals 0. So one of my solutions is going to be 5, 0. I'm going to do the same thing, but now I'm going to substitute 2 in for y, and I'm going to get that y is -3. So my other solution will be 2, -3, which are the same solutions I found by graphing, but now I did it by substitution. So now, I would like you to pause the video now and graph the two equations that are in number 2. Remember, the first equation is a circle. The second equation is a line. So go ahead and graph the two equations in number 2 and play the video once you're done. So when I graphed the circle with center at 0, 0 with a radius of 5, and I graphed my line, I can see that my line kind of grazes my circle. So it's really hard to tell where the solutions are. But I'm looking really closely. I'm going to say that my solutions are at -4, -3, and -3, -4. Now, this is why substitution for a problem like this would be a better option, because on the graph it's really hard with circles to see where exactly the two shapes are intersecting. So we are going to use substitution to get a more accurate answer for this one. So I have my two equations, and actually I already solved the linear equation for y in order to graph it. So I'm going to take that linear equation, -x minus 7, and I'm going to substitute it in for y into the circle equation. Now, remember, it's going to be squared. So I'm going to have x squared plus -x minus 7 squared equals 25. Now, remember, when you have a binomial squared, you need to multiply it by itself. So I'm going to end up doing -x minus 7 times -x minus 7. So once I simplify that, I'll get x squared plus x squared plus 14x plus 49 equals 25. Now, I'm going to put this equation into standard form, but I want to make a very important note. If I'm doing x squared plus x squared, I'm going to get 2x squareds. It is not x to the 4th. I am adding 1x squared plus 1x squared, so I get 2x squareds. Now, when I continue to simplify this, I'm also going to make my equation equal to 0. So I'll get a quadratic equation that says 2x squared plus 14x plus 24. Now, I'm going to go about trying to factor this. So the first thing I'm going to do is, since I have an a value, I'm going to check if that a value is a GCF. In this case, it is. So I'm going to factor out that 2. And that'll make this much easier to factor. If that 2 did not divide evenly, I would have to split my middle in order to factor this. Or you could always use quadratic formula. But factoring is definitely going to be the preferred method in this unit. So now I need to think about two numbers that multiply to 12 but add to 7. And those are going to be 4 and 3. So my two solutions are going to be x equals -4 and x equals -3. But remember, we need x's and y's. So I am going to take those numbers and I'm going to substitute them back into my equation. And I always am going to use the original equation just in case I made a mistake solving. So I'm going to use my original linear equation, and I'm going to substitute in -4 for x, and I'll get that y is 3. And then I will substitute in -3 for x, and I'll get that y is -4. So my two solutions are going to be -4, -3, sorry, that should have been a negative, and -3, -4. So I actually did guess correctly based on my graph, but like we said, it's very difficult in order to tell exactly where it's going to cross. Now, we're going to go through a few more examples of just using substitution or elimination without also graphing it. So for example 3, I'm going to go over substitution. Now, this one looks a little different than the other two because they're actually both already in graphing form. This is actually a pretty easy substitution. Since they're both y equals, I'm going to take the first part that's equal to y, and I'm going to substitute it where the y was in the second equation. So I'm going to have x squared plus 3x plus 2 is equal to 2x plus 3. Now I want to make sure this equation's in standard form, so I'm going to make it equal to 0, and I'll get x squared plus x minus 1 equals 0. Now, ideally, I'd like to be able to factor this equation, but if I think about what multiplies to -1 and adds to 1, it's not possible to factor this equation, so I'm going to have to use the quadratic formula. So, I'm going to do quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay. This means that I'm going to get some not real number answers. I'm going to get some decimal answers that I'm going to round, which is fine because decimals are numbers too. We get the square root of 5 over 2. So now I'm going to simplify this kind of like we did the word problems in the last unit. So my 2x solutions are going to be 0.62 and -1.62. Now, just like above, I need x's and I need y's. So I got to take these and I got to substitute them back into one of my two equations to find the y's. So typically I will pick the linear equation, but technically you could plug it into the quadratic and you should get the same answer. So if I do y equals 2 times 0.62 plus 3, I will get 4.24. And if I do 2 times -1.62 plus 3, I will get -0.24. So my two solutions would be, and I'm going to write them over here because I have a little more space over here, 0.62, 4.24, and -1.62, -0.24. So rule of thumb, unless it specifies otherwise, round your answer to 2 decimal places. All right, and number 4, we're going to use elimination. The reason we're going to use elimination is because we can kind of see that my x's and y's are already kind of lined up. So this actually works really nicely to do elimination. So if I have x squared minus y equals 6, I have x minus y equals 14. Well, right now if I add my two equations together, my y's will not subtract. So instead, I'm going to multiply that second equation by -1. And then write the new equation, so it'll be -x plus y equals -14. And now I'm going to add these two equations together. So again, be careful when we're adding these because x squared minus x is not x. X squared minus x is x squared minus x. Those are not like terms, so they cannot be combined. And it's going to equal -8. So I'm going to have x squared minus x plus 8 equals 0. Now again, this is not factorable, so I'm going to have to use quadratic formula in order to solve. So I'm going to do opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm actually going to get a -31 under my root. And remember from last unit that a negative under the root means that I have no real solutions. So this one actually cannot be solved any further. Now, I would like you to try elimination on number 5. Pause the video now, give it a try. When you are done, play to check to make sure you got your answer correct. All right, let's now check your answer for number 5. The biggest thing that I want to make sure to draw your attention to is when you solve, you have x squared plus x squared, which you'll get 2x squared, not x to the 4th. So that's a big thing. Keep that in mind. You are adding. Also, another big thing I want to point out is that here, when I take the square root of 4, you get plus or minus 2. You don't just get 2, so you're going to get 2 solutions. So I get that x is positive 2 and x is negative 2. So I have to substitute both of those in. And in this case, I get 4 for both. So one of my solutions will be 2, 4. The other solution will be negative 2, 4.